Okay, today we were whiteboarding CFPM Worksheet 3, Constant Force Particle Model, Worksheet 3, and we got through problems 1 through 3. I'm going to show you how to do problem 1, and problems 2 and 3 should be very similar to that, so you should be able to figure it out. Okay, so it says clearly draw and label the force vectors acting on each object. So I have object A and object B here. Okay, so here are the free body diagrams. Here's the free body diagram for A, and here's the free body diagram for B. One thing I want you to notice here is, notice it says 20 kilogram mass for A, 10 kilogram mass for B. I'm very nitpicky about that. The weight for B needs to be 1/2 the length of the arrow for A. Notice my normal has the same length, same magnitude as my weight for A. One more thing, notice that the tension from B has the same length arrow as the tension on A. This is because the pulley has 0 mass. Okay, you can almost think of this as equal and opposite reactions. Okay, so then we can write a couple net force equations. From object A, we could say the net force is equal to the tension. For object B, it's going to be the weight minus the tension. Okay. And as we noticed from the free body diagrams, the tension on A from the string is the same magnitude as the tension on B from the string, and that's because it's a massless pulley. Okay, then I can go ahead and plug in F net A over here for the tension. So I have F net B equals weight B minus the tension, but I'm plugging in the tension, which is F net of A. And then I can go ahead and plug in the mathematical models for F net. F net B is going to be the mass of B times A. And the weight of B is going to be mass times the gravitational field strength. F net of A is going to be mass of A times acceleration A. I'm going to rearrange this to solve for the acceleration. And what do I get when I do that is the mass of B times the gravitational field strength divided by the sum of the two masses. Realize this is our mathematical model for net force, for net force. It's the net force, which in this case, if you're looking at this, object B provides that net force, divided by the sum of all the masses, the total inertia. And then plugging in numbers here, we would have 100 newtons divided by 30 kilograms. It's 3.33 meters per second squared. So not quite the acceleration due to gravity that we normally would have for something in free fall. That's because the inertia is preventing it from accelerating at a rate of 10 meters per second each second. Then if I want to go ahead and solve for the tension, I can go ahead and use either one of these two equations that have tension. I think this one over here is easier. So I'm going to say F net of A equals the tension. F net again is MA, so it's going to be 20 kilograms times 3.33 equals the tension. And so I get a tension of 66.6 newtons. So that's one way to do it. That is, notice I had two unknowns. I had an acceleration I didn't know, I had a tension I didn't know. So I needed two equations. Two free body diagrams gives me two equations. Okay, that's just one way. There's another way we could do it. In fact, I'm going to cover this up so we don't have to look at this anymore. I could treat this, instead of being two objects, I could treat this as one object. So let's see if I can kind of show you what I'm talking about here. So all of this is one object. This is my system. Not the pulley, but the string is part of the system. There we go. Oh, of course, you can't see through there. 1 second. Okay, so in fact, let's see if I can make this a dotted line. Good. Okay, so I've got my system here. It's A and B. And so I have this force, this thing right here, the weight of this provides the acceleration. So there's only one external force here that's providing acceleration. Yeah, there's a weight force on this, but there's also this external force as support. And those two kind of cancel one another out. So the weight of A does not cause the acceleration. Neither does the normal force, the support force, cause acceleration. The tension force is internal. It doesn't cause acceleration either. No more than sitting inside of a car and pushing on the dashboard. If you sit inside of a car and push on the dashboard, that's an internal force. Does it cause the car to accelerate? No. So that internal force of tension does not cause the system to accelerate. Only the external force of the weight from B causes an acceleration for this whole system. Okay, then what I can do is write a net force equation for my free body. This should be a pretty easy one. And that would be that F net on the whole system, I'm going to call AB, is equal to the weight of B. Plug in what F net is. That's going to be the sum MA plus MB times acceleration equals the weight of B. Rearrange it, solve for acceleration. We get the weight of B divided by the sum inertia, and I get 3.33 meters per second squared, just like I got for the other way of doing it. So there's two ways to solve this problem. However, notice it says find the tension of the cord. While this way, one advantage of this way is that we can get the answer a lot quicker for the acceleration. It doesn't let us figure out the tension because it's an internal force. So that means I'm going to have to come back over here and draw another free body diagram after I figure out the acceleration, either the one for B or the one for A. I think it's actually easier to solve for A. And so then I would come right down here where it has 20 kilograms. F net of A equals tension, so 20 kilograms times 3.33 equals the tension, and I get 66.6 newtons. Either one of these ways is appropriate. The truth is you need to master both of them. The one on the left here where you just have one free body diagram, that's a very quick and dirty way of getting the answer on an AP physics test. It's very important you know how to do that. That's kind of a Newtonian way of thinking. The one on the right is a more mathematical way. It's definitely important that you know the one on the right hand side, because some of the problems you're going to do are going to be much more difficult and you're going to need two or more equations to solve the problem. Okay, and that's how you're going to do the other problems on this worksheet.